So Google just introduced TabFM, and the pitch is that you get machine learning on ordinary tables, the kind of data you already have sitting in a warehouse with no training step at all. And it's coming to BigQuery as a single AI.PREDICT SQL command. That part is a real advance, but the chart that is doing most of the persuading, the one that says it beats everything else, is basically an image in a blog post. So rather than take that at face value, I read the whole thing the way a data engineer would, and then I ran my own test. Let me walk you through what holds up and what does not. In terms of what TabFM actually is, the core idea is zero shot prediction through in context learning. Instead of training a model on your dataset, you hand it your labeled example rows and the rows you want predicted all at once, and it infers the pattern in a single forward pass with no fitting or tuning in between. Under the hood, Google says it synthesizes two existing published models, TabPFN and TabICL. So this is really a recombination of a known research line and not a brand new mechanism. It was trained entirely on synthetic tables because good real-world tabular data is scarce and hard to share. And the reason any of this matters commercially is that last point. It's going into BigQuery as a one-line AI.predict call in the coming weeks. The benchmark, because this is where I would slow down before believing the headline. The ELO ratings that rank TabFM first only exist as a chart image in the announcement. The numbers are not in the text, and I couldn't reproduce them on the live leaderboard. On top of that, there is no tuned XG boost anywhere in the top 10, and a tuned gradient boosted tree is exactly the thing most of us would actually reach for on a mid-sized table. And the leaderboard itself was co-built by the teams behind two of the models it's being compared against. None of that makes the numbers wrong. It just means that this is not a natural scoreboard, and you should treat it as self reported until somebody outside Google reproduces it. Which brings me to what AI predict is actually going to be, because BigQuery has already shipped this exact shape once. Today, you have two families of functions. The ML.star family is the model you train. You run create model, you own a versioned artifact, and you can pin it, roll it back, explain it. The AI.star family is a model Google hosts. You just call it zero setup, but you give control of the version. AI.forecast already did this for time series with Google's Time FM forecaster, and AI.predict is the same move for classification and regression. The catchword to naming, though, is that Google's own hosted version can change it underneath you. I call that vendor versioning risk, and it's a different problem from ordinary model drift because you never trained the thing, so you cannot freeze the version you validated against. So here's the part the launch chart skipped. I took a real e-commerce data set, the UCI online shopper set, where the task is predicting which sessions end in a purchase, and I gave a zero-shot tabular model and a tuned XG boost, the same 4,000 row training sample, and the same held out test set. And the honest result is that the zero shot model did edge the tuned tree on ranking quality with no tuning at all. That's real, if not a narrow win, and a fair case for reaching for one as a quick feasibility check. But then looking at speed, scoring that same test set took the zero shot model about 59 seconds, where the trained tree did it in about 5 milliseconds because a zero shot model has to reprocess its whole training context on every single prediction. That gap is the difference between a batch triage tool and something you could put at checkout. As far as where this fits in a real stack, I would keep it simple. Use it for fast feasibility triage when you want to know whether a signal is even predictive before you commit to building a pipeline on clean, small to mid-sized data. So keeping your trained models XGBoost or BigQuery ML boosted trees for production scoring for large or wide tables, and for anything a stakeholder needs explained. Don't put it anywhere real time because that latency rules out checkout time and decisions. And before you run customer data through a hosted model at all, settle the governance questions first, like how it is priced and whether the served version can change under you. So the honest read is that TabFM is genuinely impressive out of the box, and for right now, far too slow to actually deploy. Reach for it to explore, to sanity check whether a signal is predictive, not the ship. If you want the full write-up with all of the sources and the reproducible benchmark script, it's on the site at the link below. But thanks for watching, and I would genuinely like to hear what you would want to see benchmarked before you trusted a launch chart.